Okay, in this video, we're going to look at the case now where the exponent of our binomial is not an integer. So we're now looking at the case where this number here is not an integer. So in the several videos before this one, we were looking at the case where this was a positive integer this time. I'm going to look at the case where this is not a positive integer. Okay, when that happens, we get what is called the binomial series. Series here is simply a term which means summation. Okay, before we go into this, we need to introduce what is called factorial function. So factorial function. Okay, so for any positive integer n, n factorial denoted like this is equal to n times n minus 1 times n minus 2, and then all the way to 1. So that means 4 factorial is 4 times 3 times 2 times 1. So this would be 24. 3 factorial is going to be 3 times 2 times 1. It's going to be 6. 2 factorial is 2 times 1 is 2. 1 factorial is just 1. Notice that 0 factorial is also 1 by definition. So that is the factorial function. Now the combinations that we've been using are defined in the formula for combinations involve factorials. So combinations of n taking r at a time is n factorial divided by n minus r factorial times r factorial. So that means combinations of 4 taking 2 at a time, for instance, and we factor 4 factorial divided by 4 minus 2 factorial times 2 factorial. In the numerator, we're going to have 4 times 3 times 2 times 1. In the denominator, 4 minus 2 is 2 factorial, so I've got 2 factorial times 2 factorial here. So it's going to be 4 times 3 times 2 times 1, 2 times 1, 2 times 1. So the denominator is just going to be 4, and the numerator we can cancel. So this whole thing just cancels out with that. So this is going to give us 6. Right. Combinations of 5 taking 3 at a time. It's going to be 5 factorial all divided by 5 minus 3 factorial times 3 factorial. 5 minus 3 is 2. So combination of 5 taking 3 at a time is 5 factorial over 2 factorial times 3 factorial. So again, this is going to be 5 times 4 times 3 times 2 times 1. In the denominator, I've got 2 times 1 into 3 times 2 times 1. If we simplify this again, 3 times 2 times 1 we can cancel out, and then 2 here goes twice there. So this is going to be 10. So that is the combinations in terms of factorial function. Now there is another an alternative representation of this formula for combinations, which we are going to use for the case where n is not an integer. So combinations of n taking r n factorial over n minus r. So what we're going to do is we're going to want to express this just in terms of n and r. So we want to sort of get rid of this term. And so this is what we're going to do. So I'm just going to go back to those problems, those two examples that we did. So for instance, combinations of 5 taking 3 at a time. So we'll say that's 5 factorial over 2 factorial times 3 factorial. What we are going to do is we are going to divide by this one here, but we're going to leave this one exactly as it is. So this is going to be 5 times 4 times 3 times 2 times 1, 2 times 1. Then I want to keep this one. So what's going to happen is these will cancel out. So we're just going to have 5 times 4 times 3 in the numerator, and then 3 times 2 times 1 in the denominator. So in the denominator we have got 3 factorial, okay, which corresponds to that. And then in the numerator we've got a product of 3 numbers starting from n, which is this one here. So okay, next let's look at combinations of 6 taking 2 at a time. So we're going to have 6 factorial over 6 minus 2 times 2 factorial. This is 6 factorial over 4 factorial times 2 factorial. So we're going to want to maintain this one because it's the same as this. So we're going to divide 4 factorial into 6 factorial. So that's going to be 6, 5, 4, 3, 2, 1, 4, 3, 2, 1 is 4 factorial. And then when we cancel, so this is going to cancel out all those. So this thing is going to give us 6 times 5 over 2 factorial. So the general trend we're seeing here is that when we do this, we get the factorial of the second number in the denominator, and then the numerator has got the same terms as the factorial value, but starting from n. So that means from this we could, for instance, work out 12 combinations of 12, taking 3 at a time. In the denominator we're going to have 3 factorial, and then in the numerator we're going to have 3 factors starting from 12, 11 and 10. So combinations, for instance, of 18, taking 2 at a time, is going to have 2 factorial, and then 2 numbers in the numerator. So yeah, while we're here, so combinations of n, for instance, taking 2 at a time, again 2 factorial here, and then in the numerator n and n minus 1. So what we're saying is that in general, so combinations of n taking r at a time can either be written like this, okay, or if we divide this term into this one, then in the denominator we're just going to have r factorial. In the numerator we're going to have n minus 1, n minus 2, and the last term here is going to be n minus r plus 1. So the main thing here is that in the numerator we have got some r factors starting from n and going down. Now, so in the case when n is not an integer, positive integer, this is the expression we're going to use in our binomial. Okay, so maybe let's summarize what's going to happen when n is not a positive integer. So the binomial expansion of a plus b to the power n, when n is not a positive integer, we'll have, so the first thing that's going to change, so before we had n plus 1 terms, this one will have an infinite number of terms, Then the other thing, the combinations is going to be replaced by the expression which is derived above, n minus r plus 1 all over r factorial. Okay, so this is what's going to happen then. So hence we have, so a plus b to the power n will be, first term will be the same as before, second term as before, then third term. So you're going to remember before we had combinations of n taking 2 at a time. We are now going to replace that by this expression here, okay, because when n is not a positive integer, the combinations are not applicable. So we're going to have n times n minus 1 over 2 a to the power n minus 2 b squared. Just going to write one more term. The next term is going to be n minus 1, n minus 2 over 3 factorial a to the power n minus 3 b to the power 3, and then these terms are going to keep going on and on and on. So this is now our binomial statement of binomial expansion for the case n is not a positive integer. Notice that this formula also works perfectly okay when n is a positive integer. So if you like, this formula is more general than the formula that was involving combinations here. Okay, so in the next video we're going to look at some applications of the case when n is not a positive integer.